morning, everybody. As they just said, my name is Christopher Smith, and actually today's my birthday. I'm really excited about that. Thank you. And for Roger Nelson, if you go back to the lab and you see the regs going all crazy, that's probably why. So, yeah. So anyways, I'm here today to talk about a small experiment that was conducted as part of a course at the University of Colorado. And the experiment predicted the daily outcome of the Dow Jones Industrial Average. And we used 10 experienced remote viewers and used the Associative remote viewing protocol. And as you can see, 7 out of the 7 trials were predicted successfully, which is highly significant with less than 1% probability that it was due to chance. So first let me talk about what remote viewing is, and I'm sure most of you here are familiar with it, but for the sake of this talk, I'm just going to define it as the ability to gather information about a target that is distant or unseen using only the mind. And so then associative remote viewing, or ARV, would be a type of remote viewing, or a remote viewing protocol, that's used to predict the outcome of an event, and usually this event is a binomial event, meaning that there are 2 possible outcomes, only one of which can come true, like flipping a coin. A little bit about some associative remote viewing background. Some of the earlier studies were Russell, Targ, and Keith Harary, and they predicted the silver futures being really successful, predicting 9 other trials correctly out of 9. Then there was Puthoff's study that was published in '84, which predicted commodities markets 21 out of 30 times correctly, resulting in a really high probability that it's not due to chance. Another study in '95 with Targ et al. Used 2 viewers, each doing 6 sessions, so 11 of the sessions, 11 of the sessions were correct out of the 12, also resulting in a really high probability that it was not due to chance. And then Greg Kolodziejczyk, if I'm pronouncing that correctly, over the years has conducted a lot of informal experiments, being correct. He's done over 3,600 of them and was correct almost 2,000 of the sessions, so that really results in a high p-value as well. And all this information is available on his website, and I don't have that here, but you can find it relatively easy. You can come talk to me afterwards. I'll let you know. And then Jack Houck wrote extensively on his website also about remote viewing, and that's available for you to go check out as well. As you can see, using remote viewing to predict the stock market has been something that has been talked about for a while, and this is just an example of an advertisement that you can find or see on the web and in some publications. So let's talk a minute about the protocol. And the way that we did our experiment is similar to how most people do associative remote viewing experiments, and there's really 5 steps. So the first one is the tasking. The second step would be the actual viewing. The third, the judging. The fourth is when the transaction takes place. And then the 5th is the feedback, when you give the viewers the results. And there are 3 main roles involved in the experiment. There was the tasker, the viewer, or viewers in our case, and the judge. And it's possible for the tasker and the judge to be the same, although in our case they weren't. To go in a little in depth about how we did it, I'm going to take you through one of our sessions. So the tasker chose before the actual session 2 different images. One, the keyboard in this case, was associated with the market being up at the end of the day. And the second image, the Earth, was associated with the market being down. After this was decided, the tasker then came to our class in this case and simply said, draw the picture that we are going to show you at the beginning of our next class. And just based on the way that college schedules work, sometimes that was 2 days and sometimes that was more like 3 days, 3 or 4 days if it was a weekend. And we were given 5 minutes to complete the session, and we stayed in a group, and so we all were viewing at the same time. So then we viewed, and this is an example of what one of the viewers drew. And as you can see here, there's a half circle, and it says here bright colors, green, red, yellow, and white. And so then the next step, the judge took that and then examined that session, compared it to the associated images, looked for similarities between the session images and the two targets, and saw which one it compared more closely to, and then used that target to guide, actually, they did this for each of the sessions. So whichever of the two images, the associated images, had the most sessions that was sort of correlated with it, we used that to predict how the market would actually perform the next day. So in our case, we had the keyboard and the planet, the keyboard representing up and the planet representing down, and then we had this session. So the judge would look at these elements here, the half circle, the bright colors green, yellow, and white, and choose which category to put it in. This one's a little harder because there's also this square here, which could be the keyboard, but I think the judge determined that these overrid that one. And sure enough, he assigned it to the down category. So then, majority of the sessions were associated with the down category. So the tasker then bought options on the down category, and then bought in the morning, and then sold it in the afternoon before the close of the trading day. And the next day gave us feedback. And so the feedback is very important. This is where the tasker comes and shows the image associated with the actual outcome of how the stock market performed, and only how the actual outcome performed, not necessarily the image that the most images were associated with. And it must take place at the expected time. So that way, when you're viewing originally, they're tapping into that feedback event, and it closes the feedback loop. It's really important. So in our case, the market actually performed down that day, which was correlated with the planet. So this is what we showed the viewers, and it was a hit, and we were successful. So moving on, I'm going to show a few more sessions so you can kind of get an idea of the quality of some of the work that these inexperienced remote viewers are doing. So here we have a session where the viewer drew this tower-type object and described it as tall, obelisk-shaped metal, surrounded by an open space or a field. It was cold, lonely, like a person down here. Reminded them of a Washington Monument, a ladder, the radio tower, infield, or the Eiffel Tower. And the judge had to choose between these two images, a planet and the Statue of Liberty. And so, needless to say, the judge put it in the category of the Statue of Liberty, which was a hit. In this session, the viewer drew a little rabbit-looking thing here and some sort of flower-type shape, and described it as fuzzy, furry, underground. Reminded him of a small mammal and a coat rack top. And so the judge had to choose between these two images, a mountain biker and a hamster. But needless to say, he was a little confused about where this fit in and how to, this element wasn't really present really clearly in either of these two images, but upon closer inspection, he thought that maybe it looked a little bit like the hamster's foot. So it's possible, I'll leave it up to you to decide. So if we look at the individual results, we have a table here where each column represents a viewer. The green represents hits, the red represents misses, and the white represents either they weren't in attendance that day and didn't do the session, or they were just too close to actually put in one of the two categories. And as you can see, there's a lot more green than red here. And if you look down here, that indicates that 47 of the 66 individual sessions were considered hits, and that is a pretty highly significant p-value of the probability of it being due to chance being less than 0.003. And however, that wasn't exactly what we were trying to do. We weren't trying to see how many sessions we write, but rather we can predict the market in the 7 different trials. So this isn't the p-value that we were ultimately looking for. So this led to a number of different questions. And so the first question is it better to use one expert remote viewer or several inexperienced remote viewers? And if we take a look at our group results, we can see that one viewer correctly predicted 7 out of the 7 trials, but 6 correctly predicted 5 out of the 7, 2, 4 out of the 7, and 1 was off. So if you were to use just one remote viewer, you could see that if you use this one, you would do really well, but if you use this one, you wouldn't do so well. So But when you aggregate all of them, we actually ended up being correct, all 7 times. So the second question it brings up is, how can we improve the judging? This might have been the hardest part for us and potentially the hardest part in a lot of associated remote viewing, I imagine. And as an example, we had this session here, which had these cross things, separate items, bowl-shaped, these curvy things that look like creepy fingers bent over a bowl, fuzzy, round, object expanding from inside out. And the judge had to choose between the needle in Seattle or these rams here. And there's elements in both, as you can see. This kind of looks like the horns. This kind of looks like the feet of the needle. And the judge put it in the category of the needle due mostly to this and this saucer thing. But in actuality, the rams were the right one. And so this is typically known as displacement, where you're getting images of both of the 2 sessions. And that's a problem, and it's kind of hard to deal with. So judging is actually pretty subjective. So ways to improve judging is you can pick very different objects to avoid as much displacement as possible. You can determine in advance what types of criteria are going to outweigh other types, et cetera. And you can use multiple judges to further aggregate the results. So the next question it brings up is, how can we improve the transaction timing? And this is important because, as you can see, this is the Dow Jones on just one of the days of our sessions. And it starts down. It actually goes up at about 3 o'clock before finally closing down. So if our transaction time fluctuated day to day, it could be at 3 one day and then at 4:30 another day, and it would be dramatically different results. So what that indicated to us is that we needed to pick specific transaction times. Another problem we encountered is that we were trying to sell right before the close of the day when everybody's trying to sell. And so we ended up missing out on revenue, which isn't really that important in this experiment. But I think it's really important to be exactly sure when you're going to sell and a little bit before, like, say, 4:30. Some of the strengths of the study, though, is that we use multiple viewers. And as far as I'm aware, I don't know if this has been done before in the same way, where we used several viewers and then picking one on one task. And I could be wrong on that. Someone let me know at the end if I am. So we use real money, which we think might have connected the viewers with the actual outcome of what they're trying to predict, even though it's not necessarily that they even know what they're trying to predict. And the study was a predetermined length of time, which avoided viewer burnout and fatigue. So basically, I just want to conclude by saying that our study was pretty successful. For the limited scope of it, pretty successful with how it turned out. And also, given that there's only been a few handful of studies before this and only a couple that have been published, this is a really rich area for research, and I highly recommend that anybody take that on if they feel up to it. And we're currently developing, let me go back there, some new judging criteria and a schema that would track and weight viewers based on their performance over time. And so when someone's really on for a streak of time, maybe their session would be counted a little bit more heavily than somebody who's traditionally not performing as well. Anyway, that's it. Thanks a lot for taking time to listen to me. And I think I have some time for questions. I'm not sure. Yeah.
We have 6 minutes for questions.
I'd like to comment that I find it very interesting that you got good results with multiple viewers tasked at the same target event, since a number of remote viewers I've talked to informally have had the opinion that having multiple people trying to look at the same outcome, they interfere with each other and your accuracy goes down.
Yeah, I'm not aware of that in particular, but it's interesting, and that's something that further research in the field could really, sort of try to work out. And if you could isolate for the different factors like that, that would.
Hi, thanks for the presentation. You're probably aware that Greg, it's called a GZAC, I think. how you say it.
Oh, how do you say it?
I can never pronounce it. I always call him Greg K. That's what we've called
Greg
him.
K, okay.
He used a slightly different
Apologetic.
methodology. Okay.
Okay.
He used a slightly different methodology where he was the viewer and the judge. And he would show himself the targets as soon as the session was done, but only briefly, and then allot himself like a full couple minutes at the end of the day. Now, some more traditional remote viewers thought you can't do it that way just because, you'd see both targets, but his results seem to have been as good as anyone else who has done ARV. What do you think about that?
Yeah, that's actually really interesting, and I think that's also a further area of research. I think in our case that wouldn't work just because we have 10 viewers, and so you would still be interpreting, maybe if you interpreted your own, each person interpret their own. Yeah, I guess that'd be a good thing to look into, but yeah, we didn't design it that way, so yeah. Cool.
Okay, why ain't you rich, or are you?
Well, I'm not rich because I didn't invest the money in the experiment, but actually we were pretty financially successful with this, and I'd say you could be rich if you wanted to invest the time. It's anybody, as you can see, using inexperienced remote viewers, could really do this, and I'm surprised that not more people are, or if they are, they're not talking about it. One of the two.
In Larry Gossie's book on premonitions, he addresses this very issue, and he claims that all of the data that he's looked at, if people are looking to use premonitions to get rich, it doesn't work. And if they're using it for, to help somebody or have an altruistic kind of thing, that it does. And this seems to be although this is premonitions, it's similar. What would you say about that? Did you get to keep the money, or did you do something else with it?
No, actually, none of the viewers got to keep the money. They were treated to a all-you-can-eat sushi dinner afterwards. But what I would say is that it's not actually important what you're viewing. In fact, the viewers need not even be aware of it. All they're doing is viewing the target photo that they're going to be shown the next day. However, I think, Paul, do you have something to respond to that? You seem like... He's pretty aware of the topic.
All over my computer bag here. The fact of the matter is that in ARV experiments, that seems to be irrelevant. There's been lots of these done informally, just haven't been published. And the majority of them have been successful financially, and they have been done for profit, not with any kind of altruistic purpose involved. So, I want to say one thing about Greg Kolodjesic. His results actually weren't as good as most ARV experiments. It's just he did so many of them that he has the feature of large numbers that give him a huge p-value and effect size. So.
Okay, I'd like to ask you about these images. They were complicated. Could arrows, circles be better?
That's a good question. I would think that the more complicated, the more chance you are of finding elements that correlate. If you just had a circle and then somebody drew a square, and so that you were the associated images were a triangle and a circle, and they drew a square, what are you going to do with that? You can't put it in either. I think when you have more complex images, there are features of it that you can sort of nuance out of it and can more easily be placed in a category. But maybe somebody who has more experience with this want to feel that?
Yeah. Ryan Wood here. I did an associative remote viewing experiment with lotteries in like 1990. I had one viewer, did basically this whole experiment except one viewer, and it was easy to get to be statistically significant, but basically we broke even all the time. But to be financially significant, which other people have talked about, seemed to be very difficult. I guess my question, other people have brought it up, is, are you really betting any real money? Does it make a difference for anybody? $1,000 here or there. I mean, millions, tens of millions. This is where it's got to go to resolve these issues. Maybe Paul knows of people that have done tens of millions of dollars
Well-
and had success.
I can speak a little bit to that. We actually used real money, and it wasn't millions of dollars. It was more like $10,000 was our seed money. But and I know that the Puthoff experiment used, I think, 20,000 thereabouts. And I think there is some indication that using real money versus not real money does make an impact. I'm not really sure if the amount of money would make an impact.
Okay, we need to bring this to a conclusion.
Thanks a lot, everybody.
Chris.